Hello and welcome to EFM, Electronics for Makers. I'm your host, Robin Mitchell, and in today's video we're going to be looking at the MitchElectronics 555 Astable. So let's see how it works and what it can do. The chip that powers this kit is the 555 timer, and this thing has been around since the 70s, and quite literally billions are produced each year. Now the one that's in this kit is in the 8-dip package form, so it has little pins that can go through a PCB hole or the actual socket, sit in the socket itself, and that makes it quite useful for hobby work such as this kit. But going back to the 555, it is amazing to see how a chip which is based on old technology has lasted throughout the years and is still produced today, despite the fact that we have NAND flash memories, we have system on chips with like loads of processors and Wi-Fi integrated systems. This thing is still in use and still being produced in the billions. Now, interestingly, there's a little myth around here, which is that the 555 name comes from the 3 internal resistors in the 555, each being 5k ohms. But the truth is that's actually just a myth and is not really real. But if we take a look at what's inside a 555 timer, we have 2 comparators, a flip-flop, an output buffer, or technically it's an inverting buffer because its input is inverted, a discharge transistor, and our 3 famous resistors. Now, depending on the external resistor capacitor arrangement you use, you can make this thing do quite a few things. And in this example, we're turning it into an Astable oscillator, which means that the output constantly switches between on and off, or 0 and 1, or the high voltage and then 0 volts, depending on your outlook on life. Now, most explanations for the 555 Astable oscillator end there. They simply say you have an external resistor and a capacitor, and you get an Astable oscillation. But the MitchElectronics kit takes us a little bit further. While the PCB is incredibly simple with just 2 resistors, a couple of capacitors, a potentiometer, and the 555 Astable, the documentation for the kit also talks about why this works. So let's see how the 555 really oscillates. So here we have the internal diagram for the 555 timer and the schematic diagram for the 555 Astable. Now you'll see we've got some resistors here and some comparators, but please note all of this is internal to the chip, and that little chip is the IC1 in our Astable circuit. So these resistors and this capacitor is external to all of this. Now we have to make some assumptions in terms of starting conditions, and so initially the voltage across capacitor 1 here is 0 volts. So initially that is 0 volts. So we just turned it on, that's 0 volts. Now we're going to call this one comparator 1, COM1, and we're going to call this one COM2. So initially when the capacitor voltage is 0 volts, that 0 volts is connected to 2 and 6, which means both of these are connected to 0 volts. And if they're both connected to 0 volts, then comparator 2 will have an output of 0, but comparator 1 will have an output of V. Now V is going to be 9 volts in our case because we're powering it from a 9-volt battery. So in this case the output comparator 1 is 9 volts. How do we know it's 9 volts? Well, each one of these resistances are exactly the same. So each one of these points gives us a third, and a third of 9 volts, so 3, 3, and 3. So this one would have a voltage of 3 volts. This one would have a voltage between there and there of 6 volts, because it's 3 and 3, and that one would be 9 volts. So we know that this comparator would go on. This means set is on, and if set is on, then Q goes to 1, because this means it's setting the flip-flop. But the output is inverted, which means here would be 0, so this transistor turns off, and the output turns on, or 9 volts, because it's re-inverted with the use of an inverting buffer. So therefore, output goes to 9 volts. Now, because the output of the flip-flop is on, then inverted to off, the discharge transistor is not on. And if the discharge transistor is not on, then the capacitor C1 on the Astable circuit begins to charge through R1 and our potentiometer, because none of the current can go through 7 and then into ground. It all goes instead into the capacitor. So the voltage on the capacitor begins to increase a little bit like this. Like a typical charging curve for a capacitor. Eventually, the voltage on this capacitor, which is connected to both 6 and 2, will reach a point which causes some of this stuff to change. Now, when the voltage on 6 from the capacitor goes beyond 6 volts, which is this trigger point here, the comparator 2 turns on, becomes 9 volts. At the same time, this is now 0 volts. That happens when the input voltage reaches just over 6 volts. And when this happens, set is now equal to 0 volts, but the reset is equal to 9 volts, which means Q turns off, or the output of this flip-flop turns off, but the output is inverted, which means the discharge transistor now turns on, and it also means that the 1 or the 9 volt signal here is reinverted, so the output now becomes 0 volts. Now, when this discharge transistor is turned on, the current, instead of flowing through R1 through the potentiometer into the capacitor, now comes out of the capacitor through the potentiometer into 7 and then discharges into ground. So the capacitor begins to discharge and we get the classic discharge curve on the capacitor C1. Eventually, the voltage across C1 will drop below 3 volts, and when this happens, comparator 1 will switch on because the positive pin, which is set to 3 volts, will now be greater than the capacitor voltage. At the same time, comparator 2 will be turned off. This means that the set pin on the set input to the internal latch will be set to 9 volts, which means the output becomes latched to 1 or 9 volts. That's a logical one. Then this gets reinverted to become 0, so the discharge transistor turns off and the output goes back to 1 because that is also inverting. And so the capacitor begins to charge again. And this cycle keeps happening of charging, discharging, charging and discharging. And if you look at the output, what you'll get is a classic square wave, like that. And that is why the 555 Astable circuit works. Well, that's all we have time for today in this episode. Thank you for watching and see you next time.